identified by Dr. Shoichi Yamada of the National Sake Research Center, and designated yeast number 7 by the Central Brewers Union, the Masumi yeast generated immense interest among sake brewers and is now used by more than half of Japan's breweries. A yeast culture that was just started this morning. The brewery workers chant, "Become delicious sake," as they ladle a potent solution of koji enzymes into the mix to create the sugary amazake, food for the yeast. By the second day, it is clear how much the koji enzymes have broken down the rice starch into sugar. Foam begins to appear. These carbon dioxide bubbles are a sure sign that the yeast is alive and breathing. By the 8th day, the yeast culture is well and truly foaming. The foam has taken on a yellow tinge and indeed has begun to smell curiously like ripe bananas. The foam, the fragrance, and the ever-increasing volume are all evidence of the dramatic changes taking place in the yeast mixture. This spectacle reveals that living organisms are at the heart of the sake brewing process. By the 14th day, the yeast culture has consumed nearly all the sugar in the amazake and has used the energy to multiply into a concentration of more than 3 million yeast cells in every 1 cc drop. The time has come to prepare the pre-fermentation mash called moromi. The fully developed yeast culture is moved to a larger tank, and the same basic ingredients for creating more amazake, koji, steamed rice, and water, are added. However, adding the full amount of amazake at once would weaken the yeast culture, so it is instead added in 3 stages over 4 days. Once the mash reaches its full volume, fermentation begins in earnest and will continue for 21 to 25 days. During this time, countless yeast cells will transform sugar into energy, and in the process will create both alcohol and the essential flavors and fragrances of the sake. The most important element for proper fermentation is undoubtedly temperature control. If the temperature of the mash is allowed to rise, the yeast would produce alcohol too rapidly, making it impossible to produce sake with the proper balance of alcohol, flavor, and fragrance. The brewers lower the temperature of the mash by swabbing the surface of the tank with cold water, thus extending the fermentation time. This approach, known as low-temperature, long-term fermentation, is essential for producing balanced, fully mature sake.
仕込んでから10日目のもろみですね。
ああ、いやいや、ずいぶんグツグツときてますね。そうですね。
酵母という小さい生き物が酸素を吸って二酸化炭素を吐き出すという呼吸をしています。吐き出した二酸化炭素がこう泡になって見えているわけですね。まさに生きてるという感じがしますね。
そうですね。
香りもいい香りがしています。
匂います。
はい。非常にこうフルーティーな。
本当ですね。
To maintain the optimum fermentation temperature in each tank, the brewers not only analyze alcohol, sugar, and acid content, but also keep a watchful eye out for subtle changes in the volume and shape of the bubbles in the mash. When the alcohol content of the mash reaches 18 to 20%, fermentation is complete, and it is time to press the mash to extract the pure sake. The fully fermented mash is strained through fine cloth to separate the clear sake from the white sake lees. Pressing machines use compressed air to gently press 1 tank's worth of mash at a time. Out flows a glittering liquid, the rich golden color of Japanese roses. 6 long weeks after the rice was brought into the brewery and washed, freshly pressed sake is finally born.
これが酒を絞る部屋です。これが絞りたての新酒ですね。
綺麗な色してますね。
そうですね。生まれたてのお酒です。どうぞお味をご覧になってください。
そうですか。いやいやいや。はいはいはい。いやこれはどうも。